Hey everybody, welcome back to the chapter. We're going to now talk about the permeability of the plasma membrane. So I've talked about what the plasma membrane is composed of and that it has it is a fluid mosaic. And now I'm going to talk about what it means to be selectively permeable. So this means that some materials are going to be allowed to pass through while others are unable to pass through. So there are going to be molecules moving into and out of the cell freely, while other molecules are going to have to find other ways to get in or out of the cell if they want to move across the membrane. So there are multiple factors that affect the passage of molecules into and out of the cell. The size is going to be a major factor, and I'm going to just change the color really quick because I would rather use a color that is a little less, well, I guess red just seems like it's something I don't know, I want to use blue. So size. Small molecules are going to be able to fit through the membrane easier. So these can pass through much easier. And then larger molecules are going to be stopped. They're not going to be able to get through. Also, you're going to have the charge of a molecule. So nonpolar or uncharged molecules can pass through. CHARGED, what was my problem? So these are going to be able to pass directly through. So they're going to go through easier as well. There are two types of movement across the plasma membrane. We have passive transport. So with passive transport, we're moving across the plasma membrane without energy. And then that's my dog. I don't know. I think I've told you probably about my dog, but that's my dog, Frank. He likes to play with my other dog, Dudley, and they like to be right by me all the time. So, good morning. If you just woke up and you were wondering what that was, that's my dog trying to keep you guys focused on my class. So, the other is active transport. And so with active transport, there's going to be some form of energy required. Typically, the energy that is used is in the form of ATP. That's the most common energy used. So when molecules pass through the plasma membrane, they are either going to move from an area of high concentration to an area of low concentration, and that is called going down a concentration gradient. So you're moving from high concentration to low concentration. So that's 2, okay? So we have a lot of molecules on one side of a membrane and very few on the other. So what that would look like is this. So I'm just going to make little blue dots. So think of these as all kinds of molecules. On the other side has also blue dots, but not as many. So molecules are going to move faster down that concentration gradient until we have equal amounts of blue dots on each side. And so when you move down a concentration gradient, this is usually a passive process. So if you move against a concentration gradient, that means you're moving in the opposite direction. So instead, you're moving from an area of low concentration to an area of high concentration. So what that looks like, we have that same membrane and we have the same molecules, right? But in this case, they're moving up. So now we're moving from low to high concentration. So this is going to take more energy. So it requires energy. And the typical energy that it's going to use, again, like I said, is ATP. ATP is the energy currency of our cells. And so this is an active mechanism. Okay. So here you can see molecules moving from outside the plasma membrane. So this is outside to the inside of the cell. And if you're non-charged, you're going to be able to move directly across either way, right? If you are a charged molecule like hydrogen ions or potassium ions, so anything that's charged or an ion, you're not going to be allowed to move through that plasma membrane directly. There is one polar molecule that can move through the plasma membrane, and that's just because it's such a special molecule, and that is water. Water is a polar molecule, so it does have that partial positive and partial negative charge on it, but the whole water molecule itself is chemically neutral. It's allowed to move through the plasma membrane though, and most of the so it can move directly through, but most of the time it's going to move through special protein channels called aquaporins. So I'm just going to write, actually what I'll do is I'll write it here. Water typically moves through aquaporins. So that's normally how water is going to move, but, and I'm going to put a little star by it, but it can move through the plasma membrane. And then if you have a very large molecule, you're going to be stopped from going through that plasma membrane. So when I think of the plasma membrane, I really think of a bouncer at a bar who basically says, you can go in, you can't go in, you need to get out, you're going to stay, you know, whatever. And so it kind of, that's what that plasma membrane is. It allows only certain things in. It's the doorman at a club. And so the next thing we're going to do is we're going to talk about the different forms of passive transport. So with passive transport, again, no any energy is required at all. There are 3 types of passive transport we typically talk about. We talk about simple diffusion, we're going to talk about osmosis, and facilitative diffusion. All right. So I'm going to stop this video now, and in our next video, we will talk about these different forms of passive transport. Have a great day. Bye.